Okay, so in this question, we are given that if greatest integer of 5 times sin x plus greatest integer of cos x plus a constant which is 6 is equal to 0, then the range of function which is given as root 3 cos x plus sin x corresponding to the solution set of the given equation is. Alright, that means that whatever with this function is going to be, its domain is going to correspond to the equality of this given equation, right? That is what this statement is stating. So let's have a quick look at the options. Options are given. That means the solution set is not going to be a single solution, it's going to be a range of solutions, right? Because all of our options are ranges. Okay, let's have a close look at the given equation. So we know that okay, so now we know that sin x, which is like this, can only belong from +1 till -1. That's the range of sin x. Sin x belongs from -1 to 1 for all values of x which are real. That means that 5 sin x belongs from -5 to 5. If we apply a multiplicative term of 5 to sin x, then the graph is going to expand, increase in size, and its range is also going to increase, right? Okay, now we are not required to look for 5 sin x. We need to put a greatest integer on it, right? That means that we only have to look for the integer terms in this interval, right? And what are the integer terms? These are from -5, -4 till +4 and 5. So these are the terms which are of our interest, right? Okay. Now similarly, we know that cos x belongs from -1 to 1. That means the greatest integer of cos x is from -1, 0 and 1, right? Okay. Now this is also of our interest. Okay. Now what was our main equation? We need to ensure that this term plus this term is equal to -6, right? We'll take 6 on the RHS for our convenience here, right? Now it is important to note that the only way to get a sum of -6 is either when 5 sin x is -5 and cos x is -1, right? So now somebody can ask that how can I say it definitely? Why we're not exploring the all possible combinations? So we can easily check by by taking that bracket which is having the least value, right? And then now we know that we need to make greatest integer of cos x and greatest integer of 5 sin x to be equal to -6, right? Now we know that cos x can only take the values -0, 1 and 1, right? Right? Okay, so when cos x is -1, here we need -5 to make this right hand side to be -6. And when cos x is 0, we need -6 here. And similarly, when +1 is here, we need -7, right? Now, do you see that -6 and -7 here in this bracket? Do you see these two terms here? No, these are not this bracket, sorry, this one, this curly braces one. So we can see that it does not belong to greatest integer of 5 sin x. It does not belong to the range of that function. That means it is not possible. The only possible solution is this one. Okay? Alright. So now these two things are of our interest, right? So now we'll, so what does this mean? That greatest integer of 5 sin x is -5. That means that 5 sin x, let's put this as y, right? Let's put for now greatest integer of 5 sin x as y. Now what, so when we are saying that greatest integer of of some variable y is -5, that means y is bound to be between -5 and -4, right? Not in -4 is not included, sorry. So this is going to be the interval of y. So when we substitute 5 sin x here, we get this. So now this is another way of writing that sin x must belong from -1 till -4 by 5. So we have divided 5 on both sides. Similarly, when we are saying that cos x is the greatest integer of cos x is -1, that means cos x can be between -1 and 0, where 0 is not included, right? So we'll write it like that, okay? So now we need to ensure that both of these things are happening simultaneously, right? And it is also interesting to note that both sin x and cos x are negative. They're only negative value possible for both of them. Okay, now what does that indicate to us? Now that means that when we plot these values on the quadrant system, so now it is very crucial for us to understand this, that sin x remains positive in the first quadrant, positive in the second one, negative in the third quadrant, and negative in the fourth one, right? Similarly, cos x is positive in the first quadrant, negative in the second one, negative again in the third one, and in fourth quadrant it is positive. Now, if somebody is not able to learn this, there is also a graphical way of understanding this. Simply plot the graph of sin x and sin theta and cos theta, and then plot the points from all the critical points of all the quadrant, like pi by 2, pi, 3 pi by 2, and 2 pi, right? Similarly, here also you will plot these points. Now you'll notice whether from when x is varying from 0 till pi by 2, whether the graph is positive or negative. It is positive from pi by 2 till pi, it is positive. From pi till 3 pi by 2, it is negative. And from 3 pi by 2 till 2 pi, it is negative. Similarly, from cos theta, it is positive from 0 till pi by 2, negative from pi by 2 to 1, and negative again from pi by pi till 3 pi by 2, and positive from 3 pi by 2 till 2 pi. So that's what I have written here. So what is the case which is of our concern? That means we have both sin theta and cos theta as negative in our case. That means x lies in the third quadrant, right? That means x is bound between pi and 3 pi by 2. So this is some information which is which we must click instantly. We must not need an exam time to plot this quadrant graph and this thing. All right. The more mental math we'll do here, the more time we'll save. So let's find the range of fx. So what was our ultimate purpose? We need to find the range of this function, right? All right. So now we'll write fx as it is. It is through root 3 cos x plus sin x, right? So now when we see this function, now we see that we have to deal with two sinusoidal terms, which is cos x and sin x, right? Having a plus operator in between. Now to ease our calculation, we'll just try to make it a single sinusoidal function, right? And how we are going to ensure that, right? So we are going to do some trick math, right? We are going to apply some trick math. We are going to multiply this whole expression by 2 and divide by 2, right? Which will be same function as previously written. Now we note that what does root 3 by 2 means and what 1 by 2 means. Can we have, we when we have a close look at that, we can see that we can write root 3 by 2 as sine pi by 3 and 1 by 2 as cos pi by 3, right? Okay, now which identity we have put there? We have applied that sine of a plus b is sine a cos b plus cos a sine b, right? We have applied this identity, and then we have finally combined this function and written as 2 times of sine x plus pi by 3, right? Okay. So now this thing we have deciphered. Now we'll try to find more ways that how we can simplify this function. We'll use sine square x plus cos square x as 1. This identity we know. This identity also previously written is known to us. That means cos square x is 1 minus sine square x. So now why we are focusing on cos square x? Because we can write cos x as plus minus under roots 1 minus sine square x. But we know that cos x is negative in the third quadrant, right? That means we are going to take negative term in this, whatever we have achieved. Okay. Now for simplicity, let t be sin x. So what we are trying to do, we are trying to write this function in multiple ways. First, we wrote it as this form, 2 times sin x plus pi by 3. Next, we try to write it using this identity. So there are two ways of solving this question. Firstly, if I am solving using this identity, second way is also to solve it using this identity, which I'll tell later. Okay. So now let's substitute sin x as t for our convenience, and we also know previously that t belongs from minus 1 till minus 4 by 5. Okay, now ft becomes root 3 of minus under root 1 minus t square plus t, and finally we can write ft as t minus root 3t of under root 1 minus t square, right? Now we have written function in terms of t. Now we're trying to find the nature of ft, right? So what is the nature? Because this thing is not going to tell us much about the function. We just have the equation of it. When we try to find the derivative, we get to know about the more about the nature of the function. So we found out the derivative, and we can see that derivative is not negative. It is completely positive, which having roots on both numerator and denominator, and we know that roots cannot be negative, right? That means the derivative is greater than equal to 0, right? So now when we say that the derivative is always greater than 0, that means we have two cases. If the derivative is equal to 0, right? So when the derivative is exactly equal to 0, our t is plus minus 1 by 2. But from the domain of t, we can only take minus 1 by 2 because the positive part is eliminated. But t is equal to minus 1 by 2 is not on the interval, because when I write minus 4 by 5, it is 0.8, right? So now, and minus 1 by 2 is minus half. Minus half is not in this interval. It is further ahead, right? That means f is monotonic on the above interval. That means the only possible value of t when we try to substitute it in the given domain, it does not lie in that, and that is when the derivative of the function is 0, right? So now when is the derivative of a function is 0? Let's have a close look at that. For example, we have a function which is like this. So now we can see that at this point slope of the function is like this, and the derivative at this point is 0. And when such kind of points occur, we cannot say that the function is strictly increasing or decreasing, because it is increasing on this part and decreasing on this part. But now we are saying that we are not interested in this part. That means this point never comes. That means there will never be a point where derivative of this function will be 0 in our domain. That means function is monotonic. That means it is either increasing strictly or decreasing strictly in the interval. Okay. Now this is something which might be useful to us. So now we'll recall that we wrote ft as t minus root 3 under root of 1 minus t square. So now when we are saying that the function is monotonic on the above interval, that means the range of the function is f of minus 1 till f of minus 4 by 5, right? Where when we put function minus 1 in ft, we get minus 1. And when we put minus 4 by 5, we get cos x tending to minus 3 by 5, where function is also tending. So why we are putting the tending symbol and not equality? Because minus 4 by 5 exact number is not in our domain, right? Remember this practice. That means the function is tending to this minus 4 minus 3 root 3 upon 5. So what makes our final range as this? So now why we have written it inverse? Why we have put this thing here and minus 1 which we calculated as here? That means that the function, because this thing when we'll further try to make sense of it, we'll realize that this thing is greater than minus 1, right? Not greater in terms of magnitude it is greater, but in terms of value it is smaller. All right, so that means the function is decreasing because whatever we initially chose to write as the range of the function, we are getting inverse as the final solution, right? That means the function might be strictly decreasing in this given interval of t, right? And this makes a final range of f. Now there is another way of solving this, as I previously explained, that we can also use this function, right? This function we can use to solve our question, right? All right. So let's see how we are able to solve. So now we know that previously we know that x is in the third quadrant. That means it belongs from minus pi by 2 till, not minus pi by 2, pi by 2 till 3 pi by 2. But what is the exact interval, right? This we have just written based on what we got after finalizing and observing both sin x and cos x, right? But we know that these things, it is such a big interval, right? We are not having everything in this interval of our interest. That means that we need to dig more deeper, right? Currently, we know that sin x lies from minus 1 till 4 by 5. And we also know that cos x also lies from minus 1 till 0. This thing we calculated previously. But why we are taking the intersection? Because we need to work on both the things simultaneously. We need to ensure that both the domains of the x are satisfied, right? So now we'll try to understand it better by plotting the sin x graph. And let's say that when the sin x is minus 4 by 5, it is occurring at some value of x, which is alpha. And we know that sin x is negative when x is exactly 3 pi by 2, right? Okay. Similarly, we'll also try to understand the graph of cos x, where when cos x is minus 1 at the x is pi, and cos x is 0 when x is 3 pi by 2, right? So now we see that in third quadrant, that is from pi till 3 pi by 2, which is here in both cases, sin x is decreasing here, right? See this graph, it is decreasing. And cos x is increasing, right? And we also know that sin x is from minus 1 till minus 4 by 5. Now, okay, now we are more interested to find the value of x, right? So that we can directly substitute in the function which we have calculated here, right? But we cannot directly substitute it, right? Because we have x plus pi by 3 terms here. So now we need to find what is the domain of, what is the range of this internal function, not domain. We already know the domain of x. Not x, we know the domain of sin x. So now we need to find the domain of x so that we can solve the function more simply. So now we are taking inverse. We know that the sin x is decreasing, right? So when I take inverse, this on decreasing function, this goes here and this goes here on applying the inverse function. That means pi by 2, 3 pi by 2 becomes the upper limit and this thing becomes the lower limit, right? So why I have written this thing as pi plus this thing, because we need to ensure that x is in third quadrant, right? We, that's why I have written it as pi plus sine inverse of 4 by 5. So now, because sine pi plus theta is minus sine of theta, right? Okay. Now, when we are applying cos on both sides, okay, now we have found out the interval of x. Now we'll apply cos on both sides to see the domain of cos x, which is from minus 3 by 5 till 0. So why we have applied cos? Because ultimately we need to see for both sin x and cos x, which is satisfied our given calculated domain, right? So this comes under the domain, right? Minus 3 by 5 till 0, but not the 0 value. Here it is taken 0, but we cannot take 0 originally, right? That means we'll again write x where it belongs from, apply pi plus sine inverse of 4 by 5 till 3 pi by 2. Okay. Now x plus pi by 3 is of our concern, right? When we have again take a look at the function, we see that fx is 2 sine of x plus pi by 3. And when we put add pi by 3 on both sides, right? So we get this thing. Now I'm not going to say it aloud, so I'll just make you have a look at this. So this is the final range of x plus pi by 3 which we are having, right? Okay. So when I directly substitute this thing in here, right? This range I'll directly substitute here to get the final range of fx, right? And I'll put this complicated term as theta after pi. And we know that sine pi plus theta is minus sine theta. And this thing becomes minus cos of pi by 3 because it is 3 pi by 2 plus pi by 3. And after the third quadrant, sine theta becomes negative, due to which minus sign will be there. And because of this 3 pi by 2 term, it will become cos x. It will no longer remain sin x. It is just a simple conversion. Now we finally find that fx belongs from minus 2 sine theta till minus 1. Right? Now we know that sin a plus b is sin a cos b plus cos a sin b, which we knew previously, right? So why we have written here? Because ultimately we need to find sin theta, right? We have not simplified it. So sin theta becomes this thing, because it is the summation of pi by 3 plus sine inverse of 4 by 5. So we'll directly solve it. So now sin pi by 3 is root 3 by 2, and cos of sine inverse of 4 by 5 is cos of cos inverse of 3 by 5, which ultimately becomes 3 by 5. Similarly, we'll solve for this. And finally, we get sin theta is 3 root 3 plus 4 by 10. Then we substitute sin theta, we'll substitute it as 2 sin theta and minus 1, which we were having previously. After that, we'll get the same range which we were getting by using the previous method, right? This one. We're getting the same range, right? We can solve this question by both methods, and our final option becomes, which one was our option? Okay, it was the option.